So lesson 67 is going to be tree diagrams and the counting principle. So do now. What is the theoretical probability of getting heads when flipping a quarter? So you have heads, and you have tails. So heads would be 1 out of 2. So theoretically, you should get 1 out of 2, or 50%. 2. A month is chosen at random. What is the probability of not picking a month that starts with the letter J? So if you go through the months, January, February, March, April, May, June, July, August, September, October, November, December. Not picking one that starts with J. So 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. So 9 divided by 12 is 0.75, which is 75%. So what is a tree diagram? So it's a way to organize all possible outcomes. So if you were to flip a coin 2 times, the first toss you can get heads or tails, and the second toss, if you got head the first time, you get heads the second time, which would be head, 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 then tails would be head, tails. But if you got tails the first time you flipped, and then heads the second time, it would be tail, head, or tail, tail. And these right here are your results, and they're called the sample space. Okay, let's look at some problems together and make tree diagrams and find the sample space. The spinner below is spun twice. So you have A, B, or C. If I get A the first time, it can get 3 different outcomes again. It can get A, it can get B, or C. If I spin B the first time, I can get A, B, or C the second time. And if I do C, A, B, or C. So the sample space I'm going to put in the brackets, you can get A, B, AC. That's right here. Then I can get BA, BB, or BC. That would be my middle option. Or I can get CA, CB, or CC. So how many total outcomes could I get? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 total outcomes. What is the probability of getting a B twice? Well, if you look, how many times do you see BB? 1 time. So it'll be 1 out of 9 to get B twice. So at the movies, the concession stand offers buttered or unbuttered popcorn in 3 sizes: small, medium, or large. So we could either have buttered or unbuttered. And if I get buttered, I could have small, medium, large. If I go unbuttered, I could also get small, medium, or large. So my sample space would be buttered small, buttered medium, buttered large, and then unbuttered small, unbuttered medium, unbuttered large. So that's 1, 2, 3, 4, 5, 6 possible outcomes. And then what's the probability of getting a large? Well, anything that has an L in it would be large. So I can get a buttered large or an unbuttered large. So it'd be 2 out of 6. And you can reduce that to 1/3. Zoe has a choice of vanilla or chocolate ice cream, topped with sprinkles, peanuts, granola, or M&Ms. Okay, so you could have vanilla ice cream or chocolate ice cream. And she can get sprinkles, peanuts, granola, or M&Ms. And she gets chocolate ice cream with the same choices: sprinkles, peanuts, granola, or M&Ms. So the sample space would be vanilla sprinkles, vanilla peanuts, vanilla granola, vanilla M&Ms, or chocolate sprinkles, chocolate peanuts, chocolate granola, chocolate M&Ms. So you have 1, 2, 3, 4, 5, 6, 7, 8 possible choices. So what's the probability of getting vanilla with sprinkles? So that would be VS. So there's 1 possibility. So 1 out of 8. So let's move on to the fundamental counting principle. So you can use the counting principle to find the total number of outcomes, just like we did, but it's a little bit quicker and easier. If one activity can occur in X number of ways, and the other activity can occur in Y number of ways, so they're both variables, so we don't know how many ways, then both activities can occur in X, Y ways. So you just multiply. So if you look here, if you have pants, shirts, and shoes, you have 4 pants times 5 shirts times 3 shoes. You have 60 total possible outcomes for outfits. Let's look at number 2. To leave school, Chris can choose between 3 sets of stairs and 7 doors. So how many ways can he leave school? Well, there's 3 stairs times 7 doors. So if you multiply 3 times 7, you get 21 ways to leave school. 21 different ways he could leave school. 2, or B, I should say. A sweater comes in 4 sizes and 8 colors. How many different sweaters are possible? Well, you have 4 sizes times 8 colors. So multiply 4 times 8, you get 32 sweaters. See. In Mr. Hummel's math class, he has 11 boys and 16 girls. How many ways can he choose 1 boy, 1 girl? So 11 boys times 16 girls would give you, so multiply 11 times 16, 176 choices. The menu at Applebee's consists of 5 appetizers, 12 entrees, and 3 desserts. How many ways can Charlie order 1 appetizer, 1 entree, and 1 dessert? So you have 5 appetizers times 12 entrees times 3 desserts. So 5 times 12 times 3. So it's 180 different combinations. E. Emily tosses a quarter. So you could have heads or tails. So that's 2 outcomes you could have there. Then picks a letter from the word snowflake. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So from snowflake, there's 9 letters. How many outcomes are possible? So 2 times 9 would be 18 outcomes. And F. How many ways can Eric randomly dial a 7-digit phone number? Well, he could dial 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? In every single spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 ways he could dial it. And now he's going to dial it 7 different times. So it'd be 10 to the 7th power, or 10 times 10 times 10 times 10 times 10 times 10 times 10. I'm just going to do it the quicker way. 10 to the 7th power. So it's a big number. So it's 10 million. So there's 10 million different outcomes. You can randomly dial a 7-digit number.